Welcome parents and welcome students. Welcome to Concept Clarity for Physics. So today we are going to solve problems. We are going to solve problems on what, sir? We are going to solve problems on minima and maxima. Okay. Before that, please subscribe and please share it so that other friends and relatives can as well also watch and get the maximum benefit from our channel. Okay. So let us take the problem. The first problem. First problem. Function is given as minus 2 plus 3x minus x cube. Okay, what way to find x coordinates of maxima and minima. Try to solve it yourself first. Pause it and try to solve it. So as we have seen in the previous class, as we have seen in the previous session, we know that for maxima slope has to be 0 and the double differentiation of the slope has to be less than 0. And for minima, the slope is again 0 because the tangent is always parallel to the axis, right? When slope is 0, tangent is always parallel to the axis, and these are the points where you will find the maxima and minima. And but here for minima, the double differentiation, because the slope changes. No, here the slope is going like this from positive to negative, and here it is going from negative to positive. So this should be greater than 0, right? So now we'll take the differentiation of this particular function. Let us do the differentiation. I have very less space. I'll try to solve it as much as possible in this space. Here I'll divide the space. Dy by dx will become equal to, the first function will be, differentiation will be 0. This will be 3 minus 3x square, right? 3 minus, what will be 3 minus 3x square, right? This is what you're supposed to get for the differentiation, and this you're supposed to equate to 0. So if you equate to 0, what will happen? Am I right? This will become 0, this will become 0 minus 3x square. Okay. So what will happen here? 3x square, if you equate to 0, this value 2 will go, this also will become x will become equal to 0. Here x will become equal to 0, right? Let us take the double differentiation of this now. D square by dx square. How much will this will become 0 minus, it will become 3 into 2, 6, minus 6, right? Looks like there's some problem in this particular function. Looks like there is some problem in this function. Uh, it should be 3x square. Anything wrong in this function? Have I done anything wrong by applying the rules? I guess this is right, right? Oh, sorry. This won't become 0. Kya sir? This is not 0. This will become, this 3 will move here. Oh, what have I done? This 3 will move here. So it will become minus 3x square is equal to minus 3, right? This 3 will go, x will become equal to 1. No? And square root, if you use square root, it will become plus or minus 1. I write it again, x is equal to plus or minus 1. Okay, these are the possible values of x. Now by taking the double differentiation, you will get this will differentiation of 3 will become 0. Okay, differentiation of 3 will become 0 and differentiation of this will become 6x. So now let us find out double differentiation dx square when x is equal to positive 1. When x is equal to positive 1, it will become minus 6. And double differentiation when x is equal to minus 1, it will become positive 6. So this is less than 0. So less than 0 means it will be maxima, and more than 0 it will become minima. So this is the minima and this is the maxima. Okay, so we have solved one problem. Let us take up one more problem, just one more problem of minima and maxima. Clear this. Second problem. The height reached in time t by a particle thrown upward with u speed is h is equal to ut minus 1 by 2 gt square. This is the formula or the equation which is given. Find time in reaching max height. What the time taken to reach max height? So try to solve it yourself first. So the function given here is h is equal to height is equal to u speed multiplied by time minus half gt square. Okay, so for both maxima or minima, to find maxima or minima, the slope has to be 0, and we have to find it with respect to time. So derivative of dh with respect to time, right? It has to be 0 for maxima or minima. Let us find both the values. So derivative of this function will be, first you will take u out, right? It will be a product derivative. So it will be u out and dt by dt, right? U out dt by dt, and then you will say minus half g. These are all constants, right? If thrown upward with a u speed, it's not a variable, it's a constant. That's why I removed u out. Here also this is a constant. Gravity is a constant, right? Gravity is a constant. So then time is a variable here. So 2t, right? So what you will get? You will get u minus gt is equal to 0. So hence you will get time is equal to, if you solve, if you take it this side, you will become u by g, right? You will get this. Now for maxima, you want to find for maxima, right? So we will take the double differentiation of dh by dt, right? What is the double differentiation of dh by dt? Will become equal to this function. I mean derivative of this function. This is the first derivative, right? So you use a constant, it becomes 0 minus g. It become minus g, right? And this minus g is less than 0. Minus g is less than 0. So for this, for less than when less than 0, it is maximum. right? So the time taken to reach maximum height is u by g, and this is proved because the double differentiation came as minus g, for which minus g is less than 0, which is the maximum maxima condition. So because we got minus g, we got a negative sign. That is why this value of t, whatever time you found out here, will give you the maximum height for the ball or the particle. So that was it for this particular problem solving. So we'll take up many more problems in the subsequent sessions. So until then, we'll close maxima and minima. We'll go to our next topic, which is integration.